right, hello my little muffins. Thank you for watching the video notes, and I promise this will be quick and painless. Okay, so for the new unit, what we're covering are properties of circles. And it's a pretty fun unit. I like it because there's a lot of like little puzzles. So today we're going to talk about the basics and things called tangents. So real quick, the definition of a circle is pretty much, it's a locus of points. And it's a locus of points, or the set of all points that are equidistant from the center of the circle. Okay, so whenever you think of a circle, that's really the mathematical definition. It's the locus of points that are equidistant from the center of the circle. Okay, so kind of like a dog on a leash. If you're standing here holding a 5-foot leash, where would your dog go? He'd run all the way around you. All right, and the path of your dog would pretty much be your circle. Okay, so there's a couple definitions that you may or may not have heard of, and they are chord, tangent, and secant. The first thing we're going to talk about is a chord, and it's a segment whose endpoints are on the circle. So pretty much any segment that I draw where see how it in BC, they're on the edge, that's a chord, okay? There's a special chord that you guys all know, which is the diameter. And what makes the diameter special is that it goes through the center. Okay? So those are chords, and you can draw any type of chord you want in a circle, and we'll learn about special properties of those. Today we're going to be focusing on tangents, and what a tangent is, and they're really special. They intersect the circle at exactly one point. So see how this is a tangent line, KL is a tangent line, and its point of tangency is H. Okay? An important fact is that it's perpendicular to the radius at that point of tangency. Meaning, if I were to draw the radius from G to H, since KL is a tangent line, I know it's perpendicular to that line. And that's going to come in handy later on. So this is a really important fact here. The last thing we're going to talk about are secant lines. And secant lines also go through the circle, but see how they intersect the circle at 2 points. So it literally goes straight through the circle and intersects the circle at 2 points. So what I've got down here is just a little list of 4 things. So what I'd like for you to do is look at these segments or lines and determine if they're a radius, a chord, a diameter, a secant, or a tangent to circle C. Pause the video, answer the 4 questions, and then when you hit play, I'll put the answers up for you. Okay, so here are my answers for A through D. If you got any of them wrong, look back at the definition and try to figure out why. Okay, so again, in this lesson, we're going to be talking solely about tangents. So before we do that, I just want to talk quickly about coplanar circles. And pretty much when you have circles, when you draw them, they can either intersect in 2 points, like these guys. They can intersect at 1 point, and those guys are called tangent circles for the same reason tangent is called tangent, because they intersect at exactly 1 point. Or they have no points of intersection like these ones. Okay, so that's just a little thing for you to know. And then if we go down here, what we're going to talk about is drawing tangents to 2 coplanar circles. So if you look at these 2 tangents, what I've drawn in here for you is the common tangent that they shared. So these 2 coplanar circles actually have one tangent line drawn right now that they both share. Okay, I can draw actually another tangent line right here. So these guys actually have 2 common tangent lines, but the one that I had initially drawn was 1. All right. Same thing for these. This is one common tangent line that they have drawn. But again, I can come down here and draw another. All right, so those guys also have two common tangent lines. How about these ones? So for these two coplanar circles in example A, I see two common tangent lines that they share. If I draw a line here, that's a nice tangent line. It's hitting each circle at exactly one point, and then I can do the same thing to the bottom. Okay, so this guy has two common tangents. Now this one's a little sneaky. I still have the same, oops, well, you know what I mean, the same tangent kind of drawing where I've got a tangent line up here and then a tangent line up here. But there are actually two more. They've got one that goes like this, and they've also got one that cuts like this. So these two spaced apart circles actually have four common tangent lines. This last one, these guys are circles that are tangent to each other, and they have one tangent line that goes through right here. So what I would like for you to do is try the you try question and see how many tangent lines you can find between these two blue circles. Pause it, draw it, and then when you press play again, I'll have the answers drawn for you. So these circles have four common tangent lines. The next thing we're going to talk about is an important theorem that goes along with tangent lines, and here's what it says. A line is tangent to a circle if and only if it's perpendicular to the radius of the circle drawn to that point of tangency. So I kind of drew the picture here, and we already talked about it when we were doing the definition. So what we'll do is we'll kind of do some applications, but it's really important for you to know that the tangent line will always be perpendicular to the radius at its point of tangency. So if we look here, example 2 is asking me to figure out if BC is tangent to circle A. By the way, when we're naming circles, you always use the center. So this circle here in example 2 is circle A. This circle in the you try example is called circle C. Okay, so to figure this out, if this is a tangent, it must be perpendicular. And what they've conveniently drawn for me is a triangle. So pretty much what I'm trying to figure out is, if it's a right triangle, then BC is a tangent. So I'm going to use the converse of the Pythagorean theorem, all right, where 67 is my c squared and 25 and 60 are my lengths. So I've got here 60 squared plus 25 squared, and I want to know if that's equal to 67 squared. So I've got here, when you add these two up, you get 4,225. And if you square 67, you get 4,489. Since these are not equal, BC is not a tangent, because ABC is not a right triangle. Therefore, BC isn't perpendicular to BA. So what I would like for you to do is, on the you try section, can you figure out what value of x will make AB a tangent to circle C? You should have gotten 64 for the answer to this question. If you didn't, please go back and change your work. I won't accept answers without work, okay? So for this you try question, make sure you show your work to get the answer of 64. Okay, and the last thing we're going to talk about with tangents is tangent theorem 2, and this one I kind of like to think of as the party hat example. And here's how it works. If you draw two tangents from a common segment, so in this, or from a common point, so here we've got point S, and there's two tangents to circle P, and it's RS and S, or an ST. If they're drawn from a common point, just like a party hat, those two segments or tangents have to be congruent. So in this case, our S has to be congruent to ST. And it's like a little party hat. See, it's a circle wearing a hat, okay? So here's a party hat example, all right? And I know JK and JM are tangents. So since they're tangents and drawn from the same point, I know they're congruent. So I will set 3x squared minus 10 equal to 17. Then I'll go through and solve the problem. Adding 10 to both sides, I have 3x squared equals 27, which means x squared equals 3. Now remember, when I go from a squared to a, oops, not 3, 9, skipped a step. X squared equals 9. Now remember, when I go from a squared to a square root, I have to put the plus or minus in front. So x equals plus or minus 3. Now usually in geometry, we reject the negative, but if you look up here, if I plug negative 3 into x squared, it will actually work. 3 times negative 3 squared, okay, negative 3 squared is positive 9. So here I really have 27 minus 10, which gives me 17. So both answers are correct. Please pause the video and try the last example. When you're done, you can hit play to make sure you got it right. You should have gotten x equals 3. If you didn't, go back and check your work. The last thing that I would like for you to do, if you would like, is to complete this bonus problem. If you do it, I'll give you 1 bonus point on this homework assignment. You've successfully made it through our first video notes, and now I will reward you with a video. This is one of my favorite YouTube videos. Here we go. It's called Star Wars Kid. He's going to start going crazy in a second. I hope you enjoyed that. See you tomorrow.